In this section, we're going to talk about um, how to move conic sections first by translation. Translation means just moving left and right, up and down, and also rotation. So we're going to rotate it with an angle. So let's revisit the general conics equation. You can see that this equation has a lot of terms. It starts with x squared, and then you have a xy term, y squared, x term, y term, and then a constant f equals to 0. So if every single term has actually exists, then this is the full equation. Now what to notice is that this is the general conics equation, and you've seen this before because you had to complete a square on this equation many, many times, but you've never had this term before, this bxy. So xy is what we call the cross product term. And the reason you didn't see it before is that if this cross product term is actually existing, then your conic section is actually rotated. So all the conic sections that we have looked at up to this point were not rotated, therefore there was no bxy term. Okay, so let's look at this equation here. So we can complete the square to figure out what kind of shape this is. So let's have you pause the video and then complete the square to kind of rewrite this equation in standard form. So if you completed a square correctly, you should get this equation, which shows you that this is an ellipse. The second method to actually be able to figure out what kind of shape this is by solving the equation for y. What does that mean? So you see that this equation from method 1 is our standard equation, and you've learned this for a while, so when you see the standard form, you can notice that this is an ellipse, but this is not an equation that you can actually graph in your graphing calculator, correct? Because the graphing calculator has to graph something that is y equals. And so since this equation is not a y equals, you cannot graph it. So how do we change that to a y equals equation? Of course, you can start from here and then just kind of solve for y. Definitely that works. But we can actually get to that faster by just starting from this equation. Okay, so this is a technique that you have to learn for the future. How do you solve for a variable when there are two variables? Right, you have two variables x and y. How do you solve for just y and then ignore x? Well, all you have to do is just ignore x, as in thinking that any variable that is not y, or that is not the variable you care about, is just a constant. So we just think of it as just some number. Okay, so for example, since I'm solving for y, what I'm going to do is think of y as the only variable. And so I have a y squared here, I have a y here, and then everything else that doesn't have a y, I'm going to think of it as a constant. So I'm going to rearrange this equation. So I start with 16y squared, and then plus 64y, plus everything else. Everything else is the 9x squared minus 18x minus 71 equals 0. So remember, y is my only variable, and you can see that my variable goes from y squared, y, to everything that doesn't have y. So this is basically in the standard form of let's just call it y squared instead of ax squared, or ay squared, sorry, by plus c equals 0. So this is basically the quadratic equation. And so if we want to solve for y, a fast way to do this is just to use the quadratic formula. So thinking that y is my only variable. So how do I use the quadratic formula? Well, we know that quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. In this case, since we're solving for the variable y, this is equal to y. So how do we actually apply this? Well, let's just kind of do a matching game. So whatever is in front of y squared in this case is 16, that is a. Whatever is in front of y, which is 64, that is b. And then c is everything else that doesn't have a y. All right, let's go ahead and apply the formula. Y equals negative b is 64, plus or minus square root of b squared, 64 squared, minus 4, a is 16, c is this entire thing, so you gotta make sure you write everything in there with all even the x, all over 2a. All right, and now let's clean up. So negative 64 plus or minus square root of, all right, 64 squared is 4096. Okay, so this part, we're gonna multiply that together and then distribute. So 4 times 16 is 64. And then 64 is going to be distributed to everything. So there's a negative in front, so be careful of that. Negative 64, so that's negative 576x squared plus 1152x plus 4544 all over 32. Now let's combine like terms. And I'm going to put this in order, so I'm going to put the x squared first. Negative 576x squared plus 1152x 4096 plus 4544 plus 8640 all over 32. All right, let's see if there's anything we can do to clean up this. You can try to find the greatest common factor that is between the three coefficient 576, 1152, and this one. I would say try to just use this one as your first guess to see if you can basically take out the leading coefficient altogether. Now, there's a negative in front. Of course, you cannot take out a negative out of a square root, or else you're going to have an imaginary number. So we're going to leave that negative inside. In this case, we got very lucky that 576 is the greatest common factor. So I'm going to factor out 576. Notice how I'm not factoring out negative 576 because I won't be able to take it out of the square root anyways. Okay, square root 576 is 24. Negative 64 plus or minus 24, and then square root of negative x squared plus 2x plus 15 all over 32. All right, we can simplify this. We have three terms or leading coefficient that they all have something in common. So we can simplify that. I think 8 is the greatest common factor between them. So this is going to be negative 8 plus or minus 3 square root of negative x squared plus 2x plus 15 all over 4. And remember, this is y equals. So if you were to graph this y equals, which has two equations because you have the plus minus, you will get the ellipse. All right, since we already know how to complete the square, so let's have you try it with method 2. So you're going to solve for y and get the simplified equation. All right, here is the answer for method 2. Now, what we're going to do is learn how to translate axis, and this is actually quite simple. So let's say that you have this, random point somewhere, and let's call this point 3, 5, and then let's call this point A. So A is 3, 5. So 3, 5 is here. So this is pretty simple. So what we're going to do is we're basically going to say this point 3, 5 is now going to set up the new origin of this axis. So basically A is going to be our new origin. So everything is relative to A now. And so what happens is A, okay, let me rewrite this. So A, that was 3, 5, that was in the old axis. And now A being the new origin, which is what we're going to call 0, 0, is the new axis. New axis is different from the old axis, therefore we're going to put x prime, saying, okay, in the old axis, we're going to call this point 3, 5 because we're saying everything is relative to the real origin. Now that we're setting A up as the new origin, we're going to call A, this is the new axis. So now there's another question, that is, if we have just randomly another point, what is this point in the new axis and what is this point in the old axis? So what is this point relative to the original origin and what is this point relative to the new origin? And it's really not that hard, right? So you can pretty much see, let's say we call this point B. In the old axis, you can see that this point is, what is it, 6, 7, 8, 6, 7, 8. So this point is 8, 8 in the old axis. In the new axis means A is now my origin, which is right here. So then since this is 0, 0, we're going to count this way from A being 0, 0. So this is 4, 3. So in the new origin, this is 4, 3. So pretty simple. It's just saying you're going to set up a new point as the new origin and everything is relative to that. So then the question is, what is the, if you don't have this coordinate axis that you can draw graphs on, how would you be able to figure out the new point relative to the new axis really quickly? Well, here is kind of the translation formula. So in the new axis, that is x minus h. All right, what is h? H, if you remember from just kind of moving things around horizontally and vertically, h is the horizontal movement, and so that is this much to the new axis, right? To the new axis from the old one. And so to get to the new axis, you take the old one and minus h. All right, and then to get to the new axis of y, or to get to the new y coordinate, you take the original y and then minus k. Now, what is k? Again, k is the vertical movement up to the new axis. All right, that's one set of formula. We can actually go backwards, right? So let's say you know the new coordinate. How do you get back to the old coordinate? So the old coordinate is the new one plus h, and you can see that it's pretty simple. It's just adding h from both sides. And then so same thing, y is equal to y prime plus k. All right, so in this fashion, where is p, which is -1, 5, relative to the new axis? Well, since I set up A as 3, 5, you can do this really quickly since we have this graph here, right? So P is -1, 5. So -1, 5 is here. So what is this to the new axis? Well, red one is my new axis, so this is going to be -4, 0. All right, so we already know it's negative 4, 0. Let's try it with our formula and see if we get negative 4, 0. So according to the formula, the new x must be the old x minus h. H in this case is 3. So that is negative 4. The new y must be the old y. So we're following this formula. The new y is the old y minus k. So the new y is old y, that is 5, minus k. Minus k is 5. So therefore, p in the new axis must be negative 4, 0. All right, let's have you try one. Q is 3, negative 1. What is Q in the relative to the new axis? Q is 0, negative 6. All right, now let's go ahead and apply to a shape. So this is actually really, really simple. And you'll see why. So this question we already did before. That was from the previous page or the first page of this section. So we know that this is an ellipse. It says we are going to translate the coordinate axis so the origin is at the center of the ellipse. All right, so let's go ahead and just copy the standard form from the first page. So x minus 1 squared over 16 plus y plus 2 squared over 9 equals 1. So this is the ellipse, and what they want us to do is say this ellipse, if we kind of draw it out so you can see this a little better, this ellipse has a center at 1, negative 2, and this is a horizontal ellipse, so okay, let's write down HKABC. So HK is 1, negative 2, A is 4, B is 3, and we really don't need C, so I'm going to skip that for now. So A is 4, so we're going to go 4 to the right and to the left. And then B is 3, up 3, 1, 2, 3, down 3. All right, so this is my ellipse, and what they want us to do is move the origin so now it goes through the center of the ellipse. The center of the ellipse is right here, so they want us to move the origin like so. So if we did that, then the new ellipse is, if it's centered at 1, negative 2, then this equation is just centered at the new origin, therefore there is no translation, right? And then the new origin is 1, negative 2. So basically, you're going to always move the equation so that it is going through an origin, but remember, we're not at the correct original axis, so you had to put a prime there saying, okay, if I were to translate this ellipse so that it goes through the center as its origin, then this would be the new equation. I'm sorry, why did I put a 3 there? This would go through the new origin, which is 0, 0, and then you have just a very simple ellipse graph equation. Okay, now what we're gonna do is actually rotate it, and this is a little bit more involved, so I'm just gonna give you the formula instead of proving the formula to you. So the x prime equation is x cosine alpha plus y sine alpha. And then the y prime equation is minus x sine alpha plus y cosine alpha. And then so this is the equation if you want to go from original axis to the new axis with a rotating angle here. If you're going the other way, then x is equal to x prime cosine alpha minus y prime sine alpha, and then y is equal to x prime sine alpha plus y prime cosine alpha. And then what is alpha? Alpha is the angle of rotation, and that angle is between 0 to pi over 2. All right, let's go ahead and look at this next equation or question. Prove that 2xy minus 9 equals 0 is the equation of a hyperbola by rotating the coordinate axis through an angle alpha equals pi over 4. So you see how here we have an xy term. So xy term is called a cross product, and remember that was what I was saying, how it tells you that this is a conic shape that is rotated. Okay, so there is a rotating factor here. So we need to prove that this is an hyperbola, and then the angle that it's rotated through is pi over 4. Okay, so what we want to do is basically we're going to rotate it so that we're now in the x prime, y prime axis. And these new axes depend on these formula. And so what we're going to do is use the formula so that we can substitute. All right, so since we're trying to substitute x here, we're going to use this equation. So then it can substitute into x. And then same thing here, the y and the y will substitute. So we're going to put that in there. X prime and y prime are the new axis. So there's no number to substitute in. Alpha is our angle of rotation. In this case is pi over 4. All right, so let's go ahead and do that. So x is x prime cosine alpha minus y prime sine alpha. And so cosine pi over 4 minus y prime sine pi over 4. We know that cosine pi over 4 and sine pi over 4 are both square root 2 over 2. So this is square root 2 over 2 x prime minus square root 2 over 2 y prime. Okay, let's go ahead and do the same thing for y. Y is equal to x prime, x prime sine pi over 4 plus y prime cosine pi over 4. All right, same thing as before. So square root 2 over 2 x prime plus square root 2 over 2 y prime. Okay, now these are going to replace these xy's. So let's go ahead and do that. So 2 times x in this case is, I'm going to simplify this a little bit so we can do the calculation a little easier. So I'm going to pull out the square root 2 over 2. I think it will make the calculation a little easier. All right, so 2xy minus 9. 2xy minus 9 equals 0. So 2 times x in this case is square root 2 over 2 times x prime minus y prime. And then y in this case is square root 2 over 2 times x prime plus y prime minus 9 equals 0. All right, so we have all these things that's multiplied together. So remember, all the coefficients multiply together. So 2 times this, they all multiply together. This and this have to FOIL, but it's very nice because this is a minus b times a plus b. So we know that's going to be a squared minus b squared. All right, let's gather all the coefficients together. So square root 2 times square root 2 is 1/2, because square root 2 times square root 2 is 2. 2 times 2 is 4, so 2 over 4 is 1/2, times the 2 in the front, that's just 1. So we can kind of skip that. We don't have to write a 1. This part is going to be a squared minus b squared. So a squared, please make sure you put parentheses around the prime, minus b squared minus 9 equals 0, or x prime squared minus y prime squared equals 9. And then you can see that this is a hyperbola. If we want to put it in the standard form, we would write x prime squared over 9 minus y prime squared over 9 equals 1. There's a lot of topic in this section, so we are very limited on time, so there are things that we're going to skip. So for example, this angle of rotation, trying to figure out which angle we're going to rotate it through, we're going to skip. So the only last thing we want to do is called the discriminant test. It's just basically trying to figure out what conic section it will be based on the formula. And this is very simple. All you need to do is find b squared minus 4ac. So b squared minus 4ac, this is from the general conic equation, not from quadratic equation. So be careful there. If it's greater than 0, it's a hyperbola. If it's equal to 0, it's parabola. And then if it's less than 0, it is an ellipse. For example, let's look at this. So we're checking b squared minus 4ac. Now, where does abc come from? That comes from ax squared plus bxy plus cy squared. And then we have dot, 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 but we're not going to use it in the formula anyways. Okay, so in this case, 2xy minus 9. A, there is no x squared term, so that's 0. B is 2 because that's bxy, or in this case 2xy, so b is 2. C, there is no y squared term, therefore 0. So b squared minus 4ac, that is 2 squared minus 4 times 0 times 0. So that is 4. 4 is greater than 0, therefore this is a hyperbola. All right, go ahead and practice the last one. Okay, in this case, A is 1, B is 4, C is 4. So B squared minus 4AC is equal to 0. So this is going to be a parabola.